Hey guys, this is Miss Hippenmeyer here, and we are now comparing fractional values using inequalities. We are comparing 3/5 to 3/8. So first take a circle and divide it into 5 pieces. Then take a circle and divide it into 8 pieces. And we're going to think about the fact that the 1/5 slices are larger than the 1/8 size slices. So think about it. If you have three of the 1/5 slices, those slices are larger. That's going to be more than if you have 3 of the smaller size slices. So 3/5 is greater than 3/8 because these are larger size slices. So one way you can compare fractions is to just think about how big is that slice and how many of those slices do I have? When in doubt, though, you can always come up with the least common denominator. So in this case, I'll list my multiples of 5, I'll list my multiples of 8, and then from here figure out that they have a 40 in common. And then I change 3/5 to 24/40. I change 3/8 to 15/40, and then I can compare. And you will see we get the same thing. 24/40 is going to be greater than 15/40. And sometimes it's just nice to compare the same size pieces and to confidently say 24/40 will be greater than 15/40. Let's look at our next example. What I like about this example is that they're the same size slices. So I have 4 1/5 size pieces, and then I have 8 of the 1/5 size pieces. What can be confusing about this problem is that these numbers are both negative numbers. So let's graph this on the number line. So I'm going to mark 0 here, -8/5. Okay, that's more fifths than 4/5. So that means that -8/5 is going to be further to the left, further negative. And -4/5, well, that's half of the slices, so it's going to fall about there. So -4/5 is not as far to the left of 0. Now remember, the further you move to the left, the smaller the numbers become. So -8/5 is smaller or less than -4/5. Let's compare -1/10 and -1/3. Think about the size slices that you have. Take a pie and divide it by 10. Take a pie and divide it by 3. A 1/10 size piece is much smaller than a 1/3 size piece. So if you think about putting these on a number line, -1/10, you're not going over very far to the left from 0. This is a small slice. Now, -1/3, you're moving further from 0. So -1/3 we could represent as about being about there. So -1/3. So -1/10, since it's not as far from 0, whoops, didn't mean to write that. Let me fix that. Sorry, guys. It's greater than -1/3 because -1/10 is further to the right on the number line. And the further you go to the right on the number line, the larger the number becomes. Now, if that seems confusing, it might help to get a common denominator. So 30 is our common denominator. Change -1/10 to -3/30, -1/3 to -10/30, and then we can compare. And you'll still see that -3/30 is greater than -10/30. Let me show this on the number line. So we have -3/30. You go a little bit to the left, but you have to go even further to get to -10/30 because you're more negative. You're going further to the left. So this number, since it's further to the right, is -3/30 is greater than, greater than -10/30. Okay, let's look at this next example. We're comparing 3/4 to 9/10. Now, what I want you to do for this comparison is think about how far away is 3/4 from being equal to 1 whole. 3/4 is less than 1. It equals 0.75 is what it is as a decimal, okay? So we're saying this is less than 1, but how much less than 1, okay? It is how far from 4/4? Well, 3/4 is just 1/4 away from being a whole. Okay, now let's think about 9/10. 9/10 is also less than 1. It's equal to 0.9. And how far away is 9/10 away from being equal to 10/10, being equal to a whole? Well, it is one slice away. It is 1/10 away from being a whole. Okay, so which is further from being a whole? Well, 3/4 is further away from being a whole, and 9/10 is closer to being a whole. So this is actually a larger amount than this amount. So we would say that 3/4 is further from being a whole, so it is less than 9/10. And if you're unsure, you can always take a look and find the least common denominator, which would be 20. Change 3/4 to 15/20 and 9/10 to 18/20, and let's do our comparison. 15/20 is less than 18/20. So if you want to compare same size pieces, you can always get a common denominator. Okay, the last fractional comparison method that I needed to remind you of is to compare your fractions to 1/2. So I need to think of, in terms of eighths, what a half would be equal to. So if it had a denominator of 8. So think about it. 2 times 4 gives us 8. So now I multiply 1 by 4 and get that 4/8 is equal to 1/2. So 1/2 is equal to 4/8. Another way, a trick to figure out what a half would be in terms of eighths is you just say, what's half of 8? Well, half of 8 is 4, so 4/8 would equal to a half. So let's use that trick over here. Okay, what's half of 9? Well, half of 9 is 4.5. So 4.5 over 9 is equal to a half. And then, oops, I didn't mean to do that. You compare 1/2, 4.5 ninths, to 5 ninths. Okay, and look, 5 is greater than 4.5. So 5 ninths is greater than a half. Okay, so this is over 1/2. Now look at 3/8 in comparison to 4/8. Well, 3 is less than 4. So 3/8 is under a half. So if this is over a half and this is under a half, then we know that 5 ninths is greater than 3/8. And again, if you're unsure, the method you can always use is get a common denominator. And so I went ahead and changed 5 ninths to 40 70 seconds, and 3/8 I changed to 27 70 seconds. And so 40 of those would be greater than 27 of those. So I got the same answer. And that was actually our last example.